We all know someone who's nearsighted, but what if I told you that the best clues for fixing the human eye aren't just coming from the clinics? They're coming from a place most of us never get to see. Today, I'm talking to a researcher who has a backstage pass to both worlds. She sees patients in the clinic and she runs experiments in the animal lab. And what she's finding out might change how you think about your eyesight forever. So you have a really fascinating dual perspective on myopia. Mm-hmm. Not only do you work with human patients, you also do animal research.
Yes.
For the viewers who are watching, who have no science background, what makes this combination so powerful? And why can't you get this information from just humans alone?
Okay, thank you for your question. With my background as a clinician, I have been seeing patients since 2010, right? And then in the 15 years span, you see patient and treat them in certain way, but there are always, like, as science is advancing, there are always what if. Like, what if this was the condition, or how would it behave if the situation was different? And for that purpose, you need to do research with the animal model.
Yes. I see. So what does an experiment actually look like, and what animals are you working with?
So right now for my PhD, I am working with guinea pig model. Guinea pig are a very popular model in myopia research, although our lab also have a chicken model for the research. And both animal models are very well established in context of myopia for various reasons. Although there are other popular models such as mice, rats, and trisus, like marmosets. Various labs across the U.S. work with different models, and those two are the most popular one in our lab, and I work specifically with the guinea pig. So for this one, for the purpose of my PhD, what I'm studying on guinea pig is what is the interaction between the intraocular pressure, which is a pressure inside of your eye, to maintain the anatomical structure and functional integrity, just like your blood pressure, is associated or related with the eye growth in general. And for this particular one, I'm investigating an intraocular pressure lowering drug, which is already FDA approved, to see if it has potential benefit in slowing down myopia progression.
I see. Mm-hmm. So why are those models in particular popular? Is it because they're like easier to get access to, or is it because their eye is similar to humans?
So guinea pig is pretty interesting in context of myopia research, because first thing, the optics of their eye, it's very good. And they do have relatively proportionately similar pattern of anatomical structures as human beings. And the breeding time, as well as the time, like when they are born, their eyes are fully mature as well. And there are certain things that you can manipulate in their eye within a reasonable amount of time. Like some animals, if it was for primate models such as monkeys or any other marmosets or anything, they have evolutionary, like longer period of time for the development, which is relatively shorter in guinea pigs. So from the intervention perspective as well, and guinea pig model is very popular, and that's why we work with that animal model.
I see. So you said that you manipulate the eye. So are you inducing myopia onto them?
Yes. So there are, historically, there are various ways to induce myopia in guinea pigs. The first one was by suturing the eyelids. That is outdated model now. by suturing the eyelids, you deprive the eye of any kind of stimulus, let even light alone. And that induced kind of like myopia, which is not very common, like extreme cases of myopia, as if someone is born with some serious ocular defects, only develop those kind of myopia. And then there is another one called palm deprivation model. Palm deprivation model is a kind of like translucent pads that you put in front of your eye. It doesn't touch your cornea or anything. That also has a good myopia-genic model, but it has its limitation as well, because it also induces myopia in a way that there is no definitive endpoint. And the most current one that we use in our lab is a contact lens induced model. We feed our guinea pigs with the contact lenses. It's very just like you wear your ortho-K at night. Our guinea pig also wear very small, tiny, gas permeable contact lenses. And actually, it is so robust model, and it was a PhD project of one of our PhD candidates a year too. So it's very well detailed, studied, and organized model. And when you put the lens, let's suppose if we put the lens of -5 in the guinea pig eye, the eye will grow only up to the certain level that it is able to reach the target of -5, right? So as a high school student, if you know like the relationship between power and dioptric power of the eye and the focal length, so -5 diopter is equivalent to 20 centimeter, right? So your eye can only focus up to that and grow accordingly. So you change the lenses accordingly based on how much myopia you want in the field.
When I was growing up, my parents always told me not to wear the glasses that were out of my prescription.
Yes.
I didn't know that was bad for me until you just told me now that if I actually wear those glasses, my eyes would adapt to that prescription. So that's very cool.
That also happens when your eye is in the developmental stage. So there is no like definitive, as of now, there is no established like, okay, you are 30 years old, your myopia is no longer progressing. There is certain age range when myopia progresses much faster, but there are various etiological factors to that, like genetic component, your near work, less outdoor, and that is a whole different topic and might be a PhD project for someone else. Yes.
So you're running all these experiments, and I really want to know, what's the biggest, most fascinating piece of information you've learned from this?
So I was, as I mentioned earlier, I was using, so my animal model research is almost like active data collection is completed. I am processing the data. Most of them is already done to some extent, and I mean, it's still in the process of writing manuscript for that. But I have presented that in national and international conferences like American Academy of Optometry, annual meetings, as well as ARVO meetings. And what I have noticed during my process is these drugs that I was using, and both these drugs are already FDA approved for human beings for treating glaucoma. Okay, the first thing that I was trying to see is whether this drug lower IOP in guinea pigs or not, and it did. So the second thing was I was also trying to see whether it slows down myopia progression or not, and to some extent it did that too. So those both of things are very exciting things to look at, and I'm also trying to, it's still in the process of analyzing that, but I'm also looking at how it changes your blood circulation or your so our eye has 3 layers, right? The outermost layer is called sclera, middle layer is highly vascular, and that is called choroid, and innermost layer is the retina, that's the neurosensory part. And I'm also trying to see how these drugs affect all those 3 layers. So for the outermost layer sclera, I'm trying to see through like structural changes in them through electron microscopy. And the second one, I'm doing the OCT, like similar device like this, but for the animal model, which sees like how is it changing the size of the blood vessels, or how is it changing the thickness of the choroid, as well as the overall retinal health. So I'm really looking forward to analyzing those data, and maybe we'll find something exciting.
Yeah, I'm really looking for them to release it for people to actually use.
Yes.
How long does it typically take for, like, say, the things that you find in the lab to be released to the world for doctors to recommend to their patients?
So that's actually a very interesting question, and there are various confounding factors to that. First thing is, like animal model do have their own limitations because although we try to translate all the things that we see in animal model may not be translatable to the human beings because of maybe the genetic component is different or our biological age is different. But it also is more promising, like what specific thing that you are looking at, right? And for something like mine, when I'm testing like these already FDA approved drugs, that might take a relatively shorter span of time if we see that that has good translational value for human research. Versus if I was using a novel recently developed drug, that has to go to whole another layer of FDA approval. So it really depends.
Oh, I see.
Yeah.
That's very cool. And I also heard online that our eyes have their own like system that can regulate how they grow. Is that true, or is that just a myth?
That is actually true. So our eye is a great overall, like animal eye or us in general. Like our eye is a great sensor and effector. Meaning like based on what kind of stimulus is presented to the eye during the developmental phase, your eye grows accordingly. So let's say someone has been exposed to high plus power, like positive lens during their early developmental phase, their eye will behave differently. And versus someone is exposed with high minus lens, because your eye will think like when there is introduction of minus lens in front of the eye, the minus lenses are diverging, right? It diverges the light. So the light reaches behind the retina, meaning that the eye will think, oh, okay, I'm not meeting the target enough, so let me grow, and it grows. So that's why, like, and during your early developmental phase, if you are exposed to too much of near screen or less outdoor, because there is environmental factors to that as well. So it is multidimensional in that context. So yeah, the statement that you say is true. It is. It develops based on the kind of stimulus that the eye grows around with.
I see. Did we find all this information from humans, or did we find this through animal research?
I would say both. I would say both because the environmental aspects of myopia research is also very well studied in human beings, but that also has many like contributing factors, such as which geographic part of the world that we are talking about, because even the light exposure, like it's not same when you live in like Nordic countries during winter time versus if you live in tropical area, the amount of light that you get is not the same, right? And also depends on your lifestyle as well. Some people are more indoor bound and they have less visual experiences of the outdoors. So those people, or someone is living in very low dim light condition versus someone is like well lit, bigger space, and so on. Those all play key role during myopia developmental factors.
I see. So going outside more will definitely help, but it also depends on where you live.
Yeah, that is partially true. But regardless where you live, exposure to outdoor light, even if it is in a gloomy day, is beneficial than staying inside.
Okay, I'll make sure to go outside more. I love to stay at home a lot.
It's a beautiful time to go outdoor in California.
Yeah.
I mean, it always is a great time, but now, like with the spring and long days, you should definitely go out more.
Yeah.
And when you go out, I don't mean to just keep on looking at your phone.
Kind of guilty.
No. That's a big no. So when you are outdoor, you have to look like a various environmental things, such as the contrast, like beautiful flowers or anything. But if you are going outdoor looking at your phone and scrolling, that's not As helpful. No, that's helpful.
Yeah, I see. So how did discovering that our eye can control its growth, like not controlled by the brain, but rather by the eye, help doctors help their patients better?
Oh, I think that is pretty straightforward because knowing like what exacerbates your myopia versus what helps, you can, like I just mentioned to you, like because I know indoor light or being indoor inside exacerbates your myopia, or too much of near work without break exacerbates your myopia versus more outdoor and then exposure in good, not good exposure in sunlight and so on helps myopia, slowing down of myopia progression. That also, that itself is a translational value, right? So knowing what causes, so to this day, we exactly don't know what causes myopia. We see like, okay, if we do this, it causes myopia, but what is the actual signal or a driver that starts in the retina that says, okay, the rest of the eye needs to grow or I need to elongate more? We don't know exact mechanism. Is it more like a genetic factor? What signals the eye growth? We don't know yet. So that is still $1 million question.
Yeah, definitely looking forward to when that big mystery gets revealed.
Yeah. There are a lot of like myopia researchers globally working to find that. People are more aligned and definitely in treatment line, knowing like, okay, this works, but this doesn't work. But knowing the root cause, okay, just like for if you say if you are suffering from typhoid, you would know like, oh, this is some kind of bacteria that causes typhoid, right? For myopia, we don't know that yet. So that is also a mystery to solve, yet to be solved.
That's very interesting. And I feel like we've talked a lot about big discoveries. What's something that's like a smaller detail that people don't usually hear about?
I feel like I think I briefly talked about in context of myopia, right? So I think we talked briefly about it earlier too. For the first time, what we discovered, I mean, my PI, Professor Christian Wilczek, was one of the key person to establish that. She was and it was done in chicken model to establish that introduction of your eye elongates and behaves like the retina forward and backward based on the kind of stimulus that you get was established in chicken models. We don't know. Yeah, everyone would think, oh, why is someone doing research in chicken model, right? How is that translational? But for the first time, how the eye behaved, the kind of plus or minus lens that it is exposed to was discovered in chicken. So that's very simple, but that led to discovery of various kinds of like spectacle treatment or contact lens treatment for myopia.
It's very cool. And looking to future, what will the world of myopia look like in like 20 years? What do you expect it to be?
I feel like the field is ever growing, and by I think from 2010 WHO study, it was projected that by 2050, half of the world population is going to be myopic, and among that I think that might be closer to 5 billion people will have myopia by 2050. That's pretty scary. And among that, more than 1 million population, I think 1 billion population are predicted to have high myopia, meaning refractive error more than -6, -5 or -6. That has immense economic impact, socioeconomic impact, quality of life impact. So there are various things that are being undertaken, like to control myopia from various arms, such as someone is trying drugs, some people are trying gene therapy for that, some are trying to modify the environmental factor for that, some are trying various kind of contact lenses for that, some are trying different kind of light therapy for that, and some are trying the various kind of spectacles design, like novel spectacle designs for that. So the future still looks promising, but there is disparity in access to healthcare as well. It is So recently, the National Academy of Science and Technology, I think, established myopia as a disease. So that might help us in getting a lot of things under control when it comes to access to the healthcare in context of myopia management. So I think in bird's eye view, I think it might get better than reaching like 5 billion population myopia by 2050. But it has to be started from the home itself. Like everyone needs to be aware of like what is myopia before going to your first grade. Every parent should be aware, like, okay, I need to do my kid's eye exam or try to change very small behavioral habit in the home, like minimize the screen time, take them outdoor, with the annual eye exam, update their prescription, and based on that, try to find what is the best possible. If your kid are progressing from myopia, what is the best way to get in control of that? So if that starts at every household and in every health policy level, then I think we can get control of that, along with moving forward with various science discoveries too.
I'm glad that the pandemic is slowly getting better.
Yeah.
So speaking of future, AI is slowly getting more and more like reach. Do you think that this will affect the roles of optometrists?
I think there are both plus and minuses of that. So when it comes to taking, let's say, an AI can do the imaging of this one, right? Can take the images of that one, but at the same time, to do the long-term changes or have this kind of interaction, we definitely need human beings, right? So I think there are both plus and minuses of that. I think I like to think about it in my context. If I have certain disease, would I be convinced if I just talk to a robot or something like that is generating information based on the pool of data that it is gathering? Or I would talk to someone like an actual human being. I always choose the second one.
I would definitely want to talk to you. I wouldn't say a robot. Yeah. Really glad you're here.
Yeah.
And speaking of future, we must go back to the beginning, right? What inspired you on this journey of both working with humans and doing animal research?
So I think I chose optometry as a career because when I was in my 5th grade, so in our school, in primary school, we used to have rotation of the benches. Like one day you will be at first, second, third, and then as I was sitting towards the back of the class, I was not able to see the whiteboard in the class, and I was like, "What is wrong with my eyes?" And I was just 5th or 6th grade, and my father took me to, I think it might be an optometrist back then too. And then when he gave me the glasses, I was like, oh my God, this is so clear, And that changed the whole perspective. Oh, such a mundane thing as a pair of glasses could change the thinking perspective of a person in 5th grade, right? 5th or 6th grade. And so that's why that has a deep sense of like awareness in me, what it can do to like growing kids in that specific age group, and that always inspired me. Like as I grew up in high school and something, I always wanted to do something with eye, and that's why I chose optometry as a career. And and after working as a clinician in and out, I felt like it's a good thing to do like one-on-one treatment with the patient. But if I am doing research in bigger perspective and find something translational, I can change that in global scale. So that's why I moved to research, and I will continue to do this for the rest of my life.
So I love how like you were the one that had myopia, so you went through all of this to help others. That's really inspirational. And Pabita, I'm so glad that you joined us today, and I like how I'm really grateful that you explained all this complex science in a way that we can all understand. I'm really grateful to have you here.
Thank you so much for giving me this opportunity. You have a pleasant evening.
Yeah, you too. Thank you.
You're welcome.